This is honors PreCalculus A, both honors and standard. Unit 4, Polynomial and Rational Functions. Lesson 5, Graphs of Rational Functions. So today we're going to look at how to graph or tell some things about the graph from the polynomial function, from the graph of a rational function actually. Rational is a word meaning fraction. So a rational number is a number that can be written as a ratio of whole numbers. Okay, like 3/4, etc. Okay, rational fractions. So functions that express themselves as ratios of polynomial functions are rational functions. Let me give you an example here. I'm going to graph 2x cubed minus 5x squared minus 9x plus 18. All divided by x squared minus 3x minus 1. Okay? The first thing that occurs to me is to look for any vertical asymptotes. Vertical asymptotes occur when the denominator is 0 and is not canceled out by a corresponding factor in the numerator. And so factoring becomes very important. And knowing roots, this is what we've been working on all unit, factoring polynomial expressions. All right, so let's go ahead and factor the denominator, which factors quite easily. Factors of 1, actually this is supposed to be 10. Factors of 10 whose difference is 3 are 2 and 5. So x minus 5, x plus 2. Okay, so that part's easy enough. The top is not so easy, so let's do some scratch work here. Factors of 18 are 1 and 18, 2 and 9, 3 and 6, and that's about it. Factors of 2 are 1 and 2, and we can divide any of these by 1 or by 2. So if I'm going to list possible rational roots, they are plus or minus 1/2, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Any divisions by 2, 2 divided by 2 is 1, 3 divided by 2, 3 halves, 6 divided by 2 is 3, already listed, 9 divided by 2, 9 halves, and 18 divided by 2, which is 9, which is already listed. So this is the comprehensive list of all the rational roots that could possibly work. Okay, and you can guess and check and hopefully come up with it. But I've got a little prior knowledge here. I'm going to use -2. Okay, so we're going to use -2 with synthetic division. 2, -5, -9, 18. Okay, and we're going to divide, bring down 2, multiply, -4, add, -9, multiply, positive 18, 9, 2 times 9 is 18, -18. -18 and 0 is 0. Okay? And I could go on, and I think I will actually here. I'm going to apply synthetic division with 3 as well. So 3. We could write a quadratic and use the quadratic formula or factoring to do the rest as well. So bring down, 3 times 2 is 6, add, -3. -3 times 3 is 9, -9, 0. Okay? And so what we have determined is that x plus 2 is a factor, x minus 3 is a factor, and right here, 2x minus 3 is a factor. And where we get that is the factor 3 halves, which, by the way, is one of the rational roots as well, which also would have worked. Okay, so all that stuff we've been working on still applies. X plus 2, x minus 3, 2x minus 3. Okay, is our rational expression, our rational function, all factored out. Now that it's factored, we note some things. We can't divide by 0, so x cannot equal 5, nor can it equal -2. Okay. However, -2 is a removable discontinuity, so it's a whole discontinuity. There's a whole or a removable discontinuity at -2, but not an asymptote. So there's a vertical asymptote at x equals 5. Vertical asymptote at x equals 5, and a whole at x equals -2. Okay. Now for the end behavior. Okay. In order to determine the end behavior, I'm going to start with the original function. We're just going to do long division. Okay. So I'm going to take and divide x squared minus 3x minus 10 into 2x cubed minus 5x squared minus 9x plus 18. For this one, I do need to use long division. Synthetic division is not much help when dividing by a trinomial. Okay, so think x squared times what is 2x cubed? Well, that would be 2x. 2x times x squared is 2x cubed. 2x times -3x is -6x squared. 2x times -10 is -20x. Change the signs and add. That's how you subtract. Nothing. 1x squared. 11 plus 11x. Bring down. Again, x squared times what is x squared? 1. So 1. 1x squared. 1 times -3x. 1 times -10. Subtract, change all the signs, and add. Nothing. 14x. And 20, looks like 28. Okay? So if I write the remainder, I write the remainder over the divisor. 14x plus 28 over x squared minus 3x minus 10. Okay, now what happens when we're talking about end behaviors? We're talking about the limit, or what happens as x goes to infinity. As x goes to infinity, x squared is going to grow way faster than any of these other terms because it's a higher order term. And as the denominator goes to infinity, the whole fraction goes to 0. So the end behavior, or the end behavior model, is 2x plus 1. Okay, so the end behavior is going to be y equals 2x plus 1. So we have a vertical asymptote at x equals 5. We have a whole discontinuity at x equals -2. And we've got end behavior y equals 2x plus 1. Okay, let's verify that graphically here. So here we go. I've actually already graphed it here, but let's go ahead and graph the original. Y equals, you don't even have to do y equals, just 2x cubed minus 5x squared minus 9x plus 18, all divided by x squared minus 3x minus 10. Okay, so there's my graph, right? And let's check our asymptotes. We said there's a vertical asymptote at x equals 5, and there it is. Right, at x equals 5, there seems to be a vertical asymptote, and the end behavior is y equals 2x plus 1. So y equals 2x plus 1, and there we have it. The function approaches that as we move out, right? So it does verify. Now we can also verify the whole at x equals -2. Okay, at x equals -2, we're going to find there's a hole right here. Right there, you gotta be careful how you pick it, but there's a hole, -2, comma, undefined. So there's a removable discontinuity, x equals -2. So you can tell a lot about the graph of a rational function by factoring and by dividing. So all of this plays together.